What's up, guys? Quirk the Mad King here, and today I start my new segment on YouTube that I call Dev Daily, a segment where I'm Devin Daily. Okay, that was bad. I don't care. Basically, where I'm going to be learning the game design on a daily basis. Gonna make a live stream every day, hopefully to 40 minutes an hour, kind of just record and experience the entire journey from being a noob who can't code worth shit to something different, learning the game design. Originally, I would be doing it through Unity's engine. Let's see if I have this one right. I will be doing it. I usually do through Unity's engine learning system, but it's been buggy, it's been having issues, and all whatnot. So I thought maybe I'd try a different route. So as you can see here on the screen, I have my the YouTube feed up. I was already watching it. And I have my Unity editor. So I watch this YouTube channel called Mr. Dani Boy. His name's Dani, and I was going to call him Milkman. Milkman said, "Oh, check out Brackeys." So if he learned it through Brackeys, or yeah, I don't know how to fucking pronounce this shit. I thought, why not give it a shot myself? Oh, without fucking stalling anymore, let's do this shit.
Was not cheap, but these days a lot of independent engines have been made with the sole purpose.
Let's get to the actual shit.
So here's a step-by-step guide on getting started with your first video game. What you see on the screen now is what we're going to be making through this mini-series. It's really simple and arcadey, but it's always easy to add more gameplay elements and cooler graphics at a later point. Right now, let's just jump into it. So let's begin by installing Unity. If you've already done so, you can just skip ahead in the video. First, we need to go to unity3d.com. When we're here, we're going to click Get Unity Now, and we can see all of the different versions of Unity. Unless you're a really experienced developer and working in a team, I definitely just recommend the personal version. You can see that it comes with all engine features, all platforms, updates, and it's totally royalty free. So you can use it even to create commercial games. The other stuff here is mostly some in the cloud features and of course the ability to customize your splash screen. So let's go ahead and hit download now. Let's also download the installer, and this should be very similar on both Windows and Mac. Go ahead and open the file you just downloaded.
One second, having issues.
I'm going to choose 64-bit. If you're on a newer computer, you should do the same. And this here is really neat. This allows you to customize what parts of Unity that you want to download, because Unity might be fairly large. I recommend you download Unity.
I already did this shit. Fucking already have Unity. Come on.
See that updating in real time.
Oh, son of a whore.
And select default, and it's going to reopen to the default layout. And any window you don't already have open, you can go to
okay, I actually need to know how to do that.
With this. But remember, you can always go to the top right corner and select default, and it's going to reopen to the default layout. And any window you don't already have open, you can go to window and select default.
Oh,
here.
dude, that helps me out so much. All right.
Create a ground plane for a player to stand on. To do that, let's go over to the hierarchy.
All right.
You can also go under create and select 3D object cube. This spawns a new cube into our scene. Again, we can use the movement controls to have a look at it. And we can always quickly focus on it by hovering over the scene view, selecting it, and hitting F. Now the cube currently is somewhere in our scene, and it's really hard to get a look at where. So what we'll do is just go over to the transform here, right click and hit reset. And that just centers it. You can see the position is now 0 on the X, 0 on the Y, and 0 on the Z, and gives it a scale of 1 by 1 by 1. Again, hit F to focus on it. So if we go into our game view, we can now see our cube through our camera. If we want, we can take our game view here and dock it to the right so that we can see both our scene and the game view at the same time. Then we can take our camera here and we can readjust its position, and you can see that updating in real time. I'm just going to press Ctrl Z to undo that. I'm then going to select the cube and scale it up. Let's give it a scale of 15 on the X. We keep it at 1 on the Y and give it, say, 100 on the Z. If we zoom out now, we can see just how huge this ground plane is. We can then go and rename it to ground, and we can simply drag on the blue arrow here to move it over. Something like that, just so it starts about at the same point as our camera. Then let's scale of
Well, pretend that I wasn't paying attention.
Give it at 1 on the Y and give it say 100 on the Z.
Oh, okay. I know how to fucking do that. 3D object, plane. Go. Let's give it. Let's see. This is, if I'm not mistaken, it's 2. Let's do what would you do? Fine. You want to see some dummy thick in to infinity and beyond. I can't render that. Damn right. Where's my cube? No, I want that. Okay.
If we zoom out now, we can see just how huge this ground plane is. We can then go and rename it to ground. And we can simply drag on the blue arrow here to move it over. Something like that. Just so it starts about at the same point as our camera. Then let's create another object. So right click, go 3D object and then cube. Again, let's reset the transform so it's centered on our scene. We can then drag on this green arrow to move it up. Let's again hit F to focus on it. And we can see that we now have our new cube here standing on the ground. This cube is going to be our player. So let's go ahead and rename him to player. And let's also make him a bit more visible. Because right now everything is pretty boring.
Yes, plain ground.
We need to assign a material to our player, and we create a new material in the project panel. So let's right click down here.
My dude.
Go create, and then material. We'll name this material our player, and then mat for material.
How do you do that?
Let's hit enter material.
You're so fast.
And we create a new material in the project panel. So let's right click down here. Go create, and then material. We'll name.
Okay. Great. My material. Okay, I found you. Let's see. Is this handling it? Yes, it's handlings. Okay. Stop it.
Player and then mat for material, but that's optional. Let's hit enter. Now we can adjust different properties on this material. Stuff like how metallic.
Okay. Player boy skin. I'm gonna do that. Player boy skin.
It should be the smoothness of the material and the color up here. So we'll make this some kind of red. And what we can do is then simply drag our player mat onto our cube, and you can see it updating in real time. So simply let go, and it's applied.
Oh, that's be super fucking.
This material are going to update for our player.
So since I'm Quirk the Mad King, I'm good. Oh shit! I'm going with purple. Oh, that's too fucking. Oh, damn, that's kind of scary looking. Let's dip down this. No, I want metal smoothness, so I need to up the brightness of the. Ah, there we go. That works just fine. Now that'd be scary. Wait, shit. Okay, I'm gonna put that as road. I'm learnings. Hopefully I'll learn more in the first 5 minutes of this thing than I have done in all trying to learn. No, I want to put a capital. Wait. Oh, my caps lock is on. Oh, where did I do that? Okay, great. Where is material? Player boy. I'm a chain. I'm gonna make. Whatever. I'll do this. I'll just go with this one. Player boy. All right, now what?
Our camera and move it a bit closer. Again, we can move it over by simply dragging on this arrow, move it up a little bit, and that looks a lot better. So now if we were to hit play and actually run our game, not much happens. That's mostly because we haven't done any programming yet, and so we can't really control the player, but we also need to add some physics into our game. Right now, if we exit play mode, take our player, drag him up here, and hit play again, he's just going to float in the air. He's not falling down. The reason why is that we need to tell this game object to interact with the physics system.
Pretty
we go out of play mode, and
I'm calling this one. I'm pretty sure I know this answer. I think it's add component, and I think it's collider. It's a collider. I think that.
And add a new component. In our case, we want to add the physics rigid body component.
Damn it! Physics rigid body component. Where are you? Isn't that where I went? The hell? Stop doing this to me. Physics 2D? No. Physics. Oh, here we go. Alright. Let's see. Yay! It's not. So, it's gonna fall. I made it fall, guys. We are pretending I did not say that. Where's my personal insults? Where are they at? Oh yeah, here we go.
Boo! You stink!
I deserve that. I really deserve that.
See that our cube falls to the ground, and indeed it does. Right now it falls in a bit boring way, so let's try and rotate our cube a bit to make it more interesting. To do that, we switch to the rotation tool. Notice how all of the different tools are up here. Right now we have the move tool selected. We can also shift to rotation, scale, and then this one is for manipulating 2D graphics, which allows you to easily do all of the different things at the same time. You can always switch between these really quickly by using Q, W, E, R, and T. So we're going to press E to rotate, and I'm just going to kind of rotate it in a random way here. So if we now hit play, he's going to fall down, and we can now see that he has a lot more advanced physics than we were able to see before. So I'm just going to undo that rotation by pressing Ctrl Z, and I'm also going to move him down here. We can also try duplicating him. So let's press Ctrl D to duplicate, and let's move this one up and over a bit and see how they interact with each other. Awesome. So one really important thing to understand is what is making these objects behave this way. And the answer is, of course, components. So if we now exit out of play mode,
now what?
Select the player here, we can see that he has all of these different components.
Fancy.
The first one is something that you will see on all game objects called the transform component, which just keeps track of
robots
where
in
the game object is
disguise.
in space, how it's rotated, and its size. You can see we can adjust
Ooh, he got
and the game
really
object will be adjusted
fat right
accordingly.
there.
And also, if we go ahead and drag on the game object, you will see the
I
transform
wonder.
component updating. The rest of them, though, are all optional. We have
I'm so
the
abusing
mesh
this.
renderer down here,
I
which is
regret nothing.
responsible for drawing the object on the screen. If we go ahead and disable that, it's actually going to disappear. It's still in here. You can see it's still in the hierarchy, and it still has this green box, and we can move it around. But until we re-enable the mesh renderer, it's not going to be visible. Then, of course, we have the box collider. Without this, we wouldn't be able to collide with other objects. If I go ahead and disable the box collider and then hit play, this should just fall through the ground. But if we then go ahead and re-enable the box collider, you can see that it's now able to collide with everything. So to get realistic physics, we both need a collider and a rigid body, and in order to see it, we need a mesh renderer. I of course
so many ideas. My brain's hurting.
For a very simple thing, and that is choosing the shape of our object. Right now you can see it has the cube selected. We can easily go in here and change it, so we simply click on the little ball here, and we can change it to a capsule, a cylinder, a plane, a sphere, and so on. And you will notice that it's distorted, but that's just because we messed around with the scale. So we can just change that to 1, and you will notice now that it's a sphere. Of course, our box collider is still a box. So if we want this to behave like a sphere, we'll need to remove the box collider. So right click, go remove component, and instead add a sphere collider. And notice how I'm just using search here. That just makes things a lot easier. So let's just enter that. And you can see now that it has a sphere collider, so if we go ahead and hit play, it acts like a sphere. And this is of course more noticeable if we move it over, so that we can see it hitting the ground. And it's going to roll
no! No!
Another thing
Damn it.
is you can also adjust values while playing. We could take our player here, and we're still playing, and move him around. It might be a bit buggy sometimes when using the physics system, but we are able to do it. We can even go in here and say, disable the ground plane, or different stuff like that.
My legs.
But just know that any adjustment that you make while in the game and running are going to go back as soon as you quit playing. So make sure not to do it. Maybe make the game. We can go ahead and hit Control S or Command S if you're on the Mac, or go to File, Save Scenes. Then we need to name our scene something, and scenes in Unity are basically just levels. So we'll just go ahead and call this one Level 1 and hit Save. You can see now that the scene appears down here in the project panel. If we had multiple scenes, we would be able to just maximize the game back, or go to File, Save Scenes.
Alright, save scene. Save scene. I don't see a save scene. Whatever, I'll do that. Am I already messing up? I think I'm already messing up. Let's try that. Isn't this my scene? Oh, yay! Oh, sorry. Fucking Mother Nature's attacking me. Okay. Oh, I should name it. Yeah. YouTube. Oh. Malarkey. I butchered that and I don't care. Okay.
Then we need to name our scene something, and scenes in Unity are basically just levels. So we'll just go ahead and call this one Level 1 and hit Save. You can see now that the scene appears down here in the project panel. If we had multiple scenes, we would be able to shift between them by simply double-clicking.
You know what? So I don't get lost.
All of the handy tips that I could fit into this video. I know some things are probably really confusing, but really the best way for you to learn some of this stuff is by just messing around with it yourself. And then of course in the next video, we'll delve into some actual programming. So that was pretty much it for this video. Hit the subscribe button to be notified when a new video comes out. I upload Sundays and Wednesdays. And of course, if you're a fan of the channel, you can always support me over at Patreon, patreon.com/Brackeys. So thanks for watching, and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in December, and a special thanks to Sultan Al, Derek Hemskirk, Faisal Marify, James Calhoun, Robert Bonham, and Jason Latito. If you want to become a
What? It's right there. Oh, okay, this works. I'm just gotta do this and delete that and. Okay, I'm not scared no more. You still drop? I didn't break this shit, did I? No, I did not. Okay. Part 2.
Today we'll get started programming in Unity. I did a poll asking what language you guys would like to see, and the results were, well, conclusive. So today we'll be creating our first script. We'll have a look at how you can change properties and even add forces to an object. So I'm really excited. Let's just jump right into it. So whenever we want to program in Unity, we create what is called a script. To do this, we click on the object that we wanted to save on, in our case, the player, and we hit Add Component. Then we go down here, select New Script, and we can give a name to our script. In our case, it's going to be something.
How do you do that? Shit. How do you do it? What are you looking at? Oh. Add component. Add.
To sit on, in our case, the player, and we hit Add Component. Then we go down here, select New Script, and we can give a name to our script. In our case, it's going to be something like Player Movement, but you can really choose anything you like. And we select the language. In our case, that's going to be C#. So create an ad, and you can see that Unity adds a new component. And that's because scripts in Unity are pretty much just custom components that we get to tell what to do. It's also created a script file down here in the project panel, and that means that we can add it to other objects as well. So if we now select our ground, we can drag our player movement onto that in order to make it affect the ground as well. But we don't want to do that, so let's just right click on it and hit remove component. So if we go back to our player and double click on our player movement script, it's going to open up in your script editor. If you're on Windows, that's either going to be Visual Studio, which is what I'm using.
How do you do that?
It's going to open component. So if we go back to our player and double click on our player movement script, it's going to open up in your script editor. If you're on Windows, that's either going to be Visual Studio, which is what I'm using, or Mono.
How did he do that?
Which is also what you're going to be using on the Mac. It's really up to personal preference, and you're going to be able to follow along just fine with either. So this is what a script looks like just when we create it. There's a lot of scary stuff going on here. The thing about
fuck this shit up
is that at first you're just going to have to ignore most of the stuff that's going on. To clean it up a little bit, we can go ahead and delete the two using tags.
How did he do that?
He adds a new component, and that's because scripts in Unity are pretty much just custom components that we get to tell what to do. It's also created a script file down here in the project panel, and that means that we can add it to other objects as well. So if we now select our ground, we can drag our player movement onto that in order to make it affect the ground as well. But we don't want to do that, so let's just right click on it and hit remove component. So if we go back to our player and double click on our player movement script, it's going to open up in your script editor. If you're on Windows, that's either going to be Visual Studio, which is what I'm using, or Mono Develop, which is also what you're going to be using on the Mac. It's really up to personal preference, and you're going to be able to follow along just fine with either. So this is what a script looks like just when we create it. There's a lot of scary stuff going on here. The thing about learning to program is that at first you're just going to have to ignore most of the stuff that's going on. To clean it up a little bit, we can go.
Oh, hold on one guys, I forgot to add something in here. Son of a bitch. All right, window capture. Okay, no, I don't want to do you. I'm sorry for the glitchy ass visuals, but I forgot to add that. Visual Studio. Okay, let's make y'all some shit tiny. Put it right there. Alright, this ain't perfect and... Yeah! You know what we could do? Where's this main window capture? No! Where's this one? Shit. I'm unlocking you. That's a genius idea. Like, you know what? I have no idea. I'll just go with that. Fuck it. Let's get back to this educational experience. I'm sorry, I'm just laughing at myself.
Go ahead and delete the two using tags up here. And really the only thing that you should focus on right now is these two functions where it says void start and void update. And these are
you cleaned it up. Where am I cleaning up?
Which is what I'm using, or Mono Develop, which is also what you're going to be using on the Mac. It's really up to personal preference, and you're going to be able to follow along just fine with either. So this is what a script looks like just when we create it.
Okay.
There's a lot of scary stuff going on here. The thing about learning to program is that at first you're just going to have to ignore most of the stuff that's going on. To clean it up a little bit, we can go ahead and delete the two using tags up here. And really the only thing that you should focus on right now is these two functions where it says void start and void update, and these are created by Unity automatically. So let's have a look at the start function up here. The neat thing about the start function is that it will run when your game starts.
Undo.
That means that whatever code you put between this
curly
bracket and this curly bracket, so that means in here, is going to be executed when you start the game. Do note that in C#, it doesn't matter how many spaces you have. You can really space it out any way you want. You can even put it on separate lines as long as you don't split up a word like this. Let's just try and see if this is working by displaying a message to ourselves. To do that, we write debug.log and make sure to have capital letters the same places that I do because C# is cap sensitive. Then we open up a parentheses and you can see that it automatically closes one as well. Then in quotation marks we get to write a message. In our case we'll just write something like hello world. Make sure you end this line with a semicolon. You're going to be doing that a lot whenever you write a command. You're going to end it with a semicolon. If we now save this by hitting Ctrl S, you can see that it saves up here. Hit back into Unity and hit play. Nothing is really going to happen in our game view.
Did I forget something?
Unity doing that a lot whenever you write a command, you're going to end it with a semicolon. If we now save this by hitting Ctrl S, you can see that it saves up here. Hit back into Unity and hit play. Nothing is really going to happen in our game view. However, if we go ahead and look at the console here, you can see that it now says hello world.
Yay!
If you already have the console open, you can go window and then console. So the console here is used by us to debug our code. It allows us to write messages by using debug.log followed by our message. And it also displays warnings and errors about the code that we write. So we really have a love-hate relationship to the console. If something isn't working in your game, make sure to check the console and see if there's any
Yay, it's there!
That might help you troubleshoot the problem. Alright, so writing hello world in the console is a bit boring. Let's have a look at what else we can do.
To the next level.
We can do pretty much anything in Unity. We can modify values, we can add forces to objects, we can add explosions, create game functionality,
learn
for that object. To do that, we need first of all to reference this rigid body component, and Unity makes that really easy. If we go into our script and go above our functions on this empty space here, create some new lines, and then write public, then the name of our component is called rigid body, then the name of the component that we want to modify, in our case rigid.
Let's see. Okay, so alrighty then. So public did I do some shit ridged edit undo I fucked some shit up undo I think it's what CTRL-Z-D. No, I want no CT. Oh, no. I just want to undo. I don't know what I did. Undo. This might be a while. CTRL-Z. I'm clicking Control-Z. Oh my god. Undo. It's gonna be a second. I swear, I'm not retarded. I don't. Let's see if it did that. Oh, it fixed. What's this? No, what'd I do? I'm undoing that. What am I doing? Let's see. Is it open? Oh shit! I'm almost gonna break this thing before I even started. Okay, they should have fixed it. Do you know what? File. Well, I am just gonna do this, and I'm not saving this. Now it's not broken no more. Oh, that's what I fucked up. All right.
Body, and now we need to give this
under mono behavior. I'm gonna do public. There we go. It's doing what I wanted. B-O-D-Y. No, I want body. Yay! There's no weird shit.
Reference a name that we'll use internally, so we can call it something like RB for rigid body. If we save that and hit back into Unity, we should now see an empty slot here with the name of RB. It's something like RB.
Okay. So RB. Yay!
For rigid body. If the name of RB, we can then take our rigid body and drag it into that slot. So now whenever we write RB in our script, it's going to refer to this particular rigid body. That means that if we go back into Visual Studio and instead of writing debug.log here, write something like rb.useGravity, we can set that equal to either true or false. Refer to this particular rigid body. That means that if we go back into
how do you do that?
Called rigid body.
Okay.
Give this reference E for rigid body.
Okay.
Save that and hit back into Unity. We should now see an empty slot here with the
it's right there.
We can then take our rigid body and drag it into that slot. So now whenever we write RB in our script, it's going to refer to this particular rigid body. That means that if we go back into Visual Studio and instead of writing debug.log here, write something like rb.useGravity, we can set that equal to either true or false. In our case, we're going to set it to false and then of course end with a semicolon. So save that, let's hit in a Unity and let's see if this is true or false. In our case, we're going to set it to false and then of course end with a semicolon. So save that, let's hit in a Unity and let's see if this value isn't going to change when we hit play. So let's hit play and indeed the use gravity changes to false. We can see that our cube here is hovering in the air.
Oh, I get it.
The two would collide. You can see just how cool of an effect that
Dude, that's actually pretty
just
dope.
Editing a tiny little property. We can also make our rigid body do different things. If we quit playing, go back into Visual Studio, we can actually add a force to that rigid body. So instead of writing rb.useGravity, let's write rb.addForce. And again,
add the force within. Okay, where are you at? I want to try that. I want to try that. Void start. Oh, okay. So let's just do rb dot add force. No, I need these. What? What's wrong? Ah, son of a bitch. 1 second. I'm going AF. I'm going to some Sorry about that. I'm all golden and I don't see this shit. Let me just know what the hell to go. Where'd go the editing? Hold on. I got this shit. Display capture. What's this one? I didn't even close you. Oh, whatever. Let me just get that shit back in that bitch. I don't know. I didn't care. Just do this shit and I'll just fucking pop it out of existence when I'm not doing it. Okay.
And we open a parentheses, close a parentheses, and then end with a semicolon. However, you can currently see that this is displaying red. And the reason why is that we need to specify a few things. These are called function arguments. The add force method wants to know how much force it should add in the different directions. So we could start with 0 on the x-axis. We could do something like 200 on the y and maybe 500 on the z. Notice how I separate each number with a comma. We can then hit save, go back into Unity, and when we now play,
I wasn't looking.
Y and maybe 500 on the Z. Notice how I separate each number with a comma. We can then hit save.
Okay, I'm gonna do this shit. I just want to go in here. I'm gonna go 0, comma 200, comma 500. I don't like how it fucking deletes everything. Okay. What's this thing? It looks like it's fine. I'm gonna save. We'll see what I did.
Into Unity, and when we now play, we should see a force being applied to this object. Awesome. So head back into.
I want to see that. I did a thing. Oh my god! I did that, guys. I'm a little skinny schoolgirl. I made it fly. I need to see that. Let's go. Just gonna watch it whoosh. Wait, it's not gonna make a difference. I didn't move the camera. We are not gonna talk about that. I'm a dummy. Let's just no. I want to move the camera up. No. What the shit? Let's try that. Okay. Let's get you seen up here. Messina. Oh, it's too high. I should probably have to take the camera and main it to a certain point of view. Was probably what they're going to teach me in a second.
Visual Studio, and what we want to do is not only add a force in the beginning of the game, we want to add a constant force in order to move our object forward. To do that, we can't use the start method. Remember, this is only called once right when we start the game. However, our update function is called once per frame. That means that whenever the computer draws a new image, and it does this multiple times a second, this function is going to run. So let's again put this on a new line to make things a bit easier to see, and we can then write rb.addForce just like we did up here. We can input 0 on the x, 0 on the y, and let's try 200 on the z. Again, remember to close it with a
okay, I can do that. RB and not comma. Add force parenthesis 0, 0, 200. Let's close you and do that. File save asset. Now let's see how similar I did with him. Let's see this shit. Okay, now how long does it happen? Oh my god! He's taking lift off. Shit. I did not.
Let's also take our entire start function up here and remove it. So now we hit save, go back into Unity, hit play, and we should see our cube just launching into the distance. And indeed we do. However, even though our game currently runs just fine and we get no errors in the console, we do actually have an error in our code. If we stop playing, head back into Visual Studio, we can see that everything looks just fine. But that's one problem. And that is, if this method is called once per frame, and we add a fixed amount of force each frame, how much force we add over a second is actually going to totally depend on our frame rate. And that means if you have a really good computer, that is drawing a bunch of frames a second, the cube is going to travel faster than on a slower computer that doesn't run as many frames per second. And the frame rate can even vary on the same computer. If a bunch of stuff is going on the screen, the computer usually slows down a bit in order to handle everything. Or if something is happening in the background, that might also change your frame rate. So in order to even out these differences, what we do is we multiply this value, the 200 here, with what is called time.delta time. This is a bit confusing, but basically what time.delta time is the amount of seconds since the computer drew the last frame. So if the update is running 10 times a second, this value is going to be 0.1. And if it's running 20 times a second, this value is going to be 0.05. So the higher the frame rate, the lower this value is going to get. And therefore it's going to even out the advantage that you would get if you were running on a good computer. If you don't get this right away, that's totally understandable. I sure didn't the first time, just right after me for now. So if we now save this and go back into Unity, we should actually see a pretty big difference.
Let's try that again.
If you don't get this right away, that's totally understandable. I sure didn't the first time. Is going to be 0.1. And if it's running 20 times a second, this value is what is called time.delta time.
What symbol is that?
The cube is going to travel faster than on a slower computer that doesn't run as many frames per second. And the frame rate can even vary on the same computer. If a bunch of stuff is going on the screen, the computer usually slows down a bit in order to handle everything. Or if something is happening in the background, that might also change your frame rate. So in order to even out these differences, what we do is we multiply this value, the 200 here, with what is called time.delta time. This is a bit confusing.
Oh, so that's a multiplication symbol. Okay. Where is that? Okay, I'm thinking it's going to be this. Did I space it? Then times. Time dot. Delta time close, and that should do the trick if that's what this man is saying.
But basically what time.delta time is the amount of seconds since the computer drew the last frame. So if the update is running 10 times a second, this value is going to be 0.1. And if it's running 20 times a second, this value is going to be 0.05. So the higher the frame rate, the lower this value is going to get. And therefore it's going to even out the advantage that you would get if you were running on a good computer. If you don't get this right away, that's totally understandable. I should do it the first time, just right after me for now. So if we now save this and go back.
What do I do? Oh, hold on. I think I need to go. What'd I do? Where's void start? There's the public class. Public / starts. Frame. Oh, he literally just wiped out this entire fucking section. I don't think I fucked anything up. I mean, it looks just about. Yeah, this has to be it. File. Save. This should made it work. No? What?
So if the update is running 10 times a second, this value is going to be 0.1. And if it's running 20 times a second, this value is going to be 0.1. I sure if it's running is going to didn't the first time. Just this, our cube is not moving now at all. And that's because on my system, it's drawing a lot of frames, and so overall the value gets a lot smaller than it was before. The workaround for this is super simple. We just need to go into our script and make this value bigger. I'm just gonna add another 0. Save that.
You're fuck. I thought I broke something. This asshole. This guy was messing with my head. I'm gonna edit a 0. Why can't I just fucking...
That, go into Unity, hit play, and we should see him just storming off here. It doesn't look like much of a difference, but now we can at least know that it looks the same way on all systems. The final thing we're going to do is yet another one of those, it doesn't look like it's wrong, but it's actually a little wrong kind of things. And that is that Unity really likes it if we use what is called fixed update instead of update for calculating physics. And in our case, we are using the Unity physics system. So just make sure that whenever you do physics stuff, if you're adding forces or changing velocity, do it.
Okay, Droid. Okay, so I'm gonna put... There we go.
Inside the fixed update, Unity likes that a lot better, and it's going to make everything look a lot smoother when you collide with stuff. Also, if you find all of this confusing, I totally get it. One thing that you can do is use the fact that we can make comments inside of our code. So you can see this line here is grayed out. That's because it's marked with these 2 slashes. Whenever you create 2 slashes and follow it up with some text, that text is not going to be included in your code. And so it allows you to say stuff like this. So just go through your code and add some comments to help you out. You can even add comments at the end of a line. Also, I see a lot of beginners using spaces to indent their code. I find it a lot easier to just use tab, but it's something programmers have argued about for decades. So let's just save our code a final time and enjoy the result. Until the next video, you can of course play around with this by adding more objects into the game.
Holy shit. How long has this video been going? Kind of curious. Holy shit. I have had hardly any fucking progress.
Hello everyone, in this video we'll make our player move. To do that we'll have a look at variables, if statements and player input. So if you want to make games in Unity, this video is pretty much just each video over at DevAssets. This is a website I created. We have a modern weapons bundle, some cool looking. So if we go to devassets.com, this is a website I created where you can download really high quality 3D models such as this Western props pack. We have a modern weapons bundle, some cool looking sci-fi.
I'm gonna check that. I might. Hey, I found it. Oh, I found it. God. Oh my god. Dude. Powered by Brackeys. Oh yeah. Oh yeah.
Vehicles and a lot more. If we go to browse, scroll down to the bottom here and click how to make a game, we get to this page where you can download all of this stuff. I've seen a lot of tutorial makers make their project files paid, but I don't really think that's fair to you guys. Instead, as with everything on the site here, I've made it pay what you want. So you can of course go ahead and grab it for free or choose to support me with some amount. You can just click the one that...
Wow, you know, I just respected this guy severely. So did he? Yeah. This man, I can't do it, but I'm you know, pounding my chest and giving this man respect right here, because that is wow. You don't see a lot of guys that give you an option to buy for free. Wow. I had this guy. I like this guy.
You can afford here and then hit the blue button and you're good to go. So back to the video. In the last one we made our cube fly forward by adding a force. Right now our primary issue with this is that our player doesn't stay on the ground. He just starts rotating and jumping and goes crazy. One way to fix this is to go to the player, find the rigid body and add some constraints. We could for example freeze the rotation on the x-axis and that should result in smooth movement. However, we do want our cube to be able to rotate so that when he collides with something it's going to look cool. So let's uncheck that and instead let's create a physics material. The reason for the cube jumping around is that by default there's friction between the cube and the ground. By using a physics material we can choose how much friction we want. So let's right click in the project, go create and then select physics material. We can rename this to something.
Okay. Right click.
Want. So let's right click in the project, go create and then select physics material. We can rename this to something like slippery and we can set both the dynamic and the static friction to 0. Then we can drag this onto our ground and you can't see it being applied, but if we go ahead and select our ground we can see that the material under the box collider is now set to slippery. But that means that if we hit play now, There's no friction between the cube and the ground, and he's just going to slide off, and that's without restraining his rotation. So if we now select the player and double click on our player movement script. On this line, we're adding a forward force of 2000, and then of course multiplied with time on our player movement script. On this line now, there's no friction between the kinetic friction to 0. Then we can drag this onto our ground, and you can't see it being applied, but if we go ahead and select our ground, we can see that the material under the box collider is now set to slippery. And that means that if we hit play now, there's no friction between the cube and the ground, and he's just going to slide off, and that's without restraining his rotation. So if we now select the player and double click on our...
So if I take it by the ground, that's slippery. Now which one do I got turned to 0?
That means that like slippery, and we can set both the dynamic and the static.
Both dims. Put to 0 and put to 0. Then I'm gonna put this to 10. No, I meant 10. No, I said 10. Fine, hell, fine. What? Fine, let's see that happen. Let's see. Is it gonna go? Oh yeah! Let's change that camera just so I can see the whole damn thing. Let's. I'll rotate you. I'll put you further back. See how to do that one so I can get a good view. I just realized, and let's go a little bit further. Let's stop you. Just so I can get a whole damn view. It's off to Neverland. Okay. Now what?
If we hit play now, there's no
Slippity.
Of 2000, and then of course multiplied with time.delta time. However, it would be really neat if we were able to modify this value in the inspector instead of just hard coding this into the line. To do that, we use variables. In C# I like to think of variables like containers. Just like you can store items in a box, you can store data in a variable. In the beginning, we focus on storing simple values like numbers or text, but variables can be used to store way more complicated data. Each variable is given a name. This pretty much just means slapping a label on the container so that each time we use that name, it refers to the data of the variable. We also have to specify what type of data we want to store. For starters, you should learn and memorize the 4 fundamental data types. Integer, we just write int. This stores a whole number. It can also be negative. Float, this stores a number with decimals. String, this stores a piece of text. And boolean, we just write bool, and this is the simplest of all the data types because it can only have 2 values, true or false.
I'll be completely honest with you right here. I've been wanting to see this right here because when I first tried to start learning coding, it's like 4 years ago. I had a little dinky old little laptop. It was maybe about $200. Got it on Black Friday. I started and I couldn't hardly run Unity. I was doing the basic of the basic. It was rollerball. I think it was what was the lesson? Let me check. I'm curious. But I didn't fuck up the stream. No, I did not. I mean, kind of. You guys can see me now. Let me check. I'm curious. Unity Hub. But, let's see. Learn tutorials. It was, probably in projects. It was Rollerball. And, now let's get back to which one was this one. This one was No. Bingo. There we go. But it was... That's what nailed me. I couldn't understand it. Nothing on the internet I could find that explained it, what it did.
Creating a variable looks like this.
But
Unity also allows us to edit a variable in the inspector. To do that, we mark it as public. However, this variable is currently unassigned. It has no value. We can assign the variable a default value by simply typing equals and then the value. To get the value of the variable in code, we simply write its name. Like here, where we are printing the value 10 to the console. We can of course also edit the value of a variable. Here we set it equal to 5, and here we add 1 onto the current value, making it 6. So if we want to turn this number into a variable that we can edit in the inspector, we'll go up here and create some space. We'll write public float because we want a number.
It's under rigid body, so space. Nope. Oh man.
That we can fine tune with decimal places. Then we need a name. In our case, we could do something like forward force, and we can set a default value. In our case, we'll just set that to the same 2000. Then we can substitute this number with forward force. So we'll just take the forward force here and paste it down there. If we now save, go back into Unity, we can see that we are now able to adjust the forward force in the inspector. We could set it to 4000 or to 1000. If you click and drag on it, you can even fine tune like this, and you can even edit it while playing. So now of course we need to change this comment here. Instead we'll change it to something like add a forward force. And it's time to have a look at doing some player input. Now the fundamental thing to understand when doing player input is the if statement. If you make some room beneath our add force method here, we can write if, open and close a parenthesis, and then open and close some.
Alright, let's... I want to scroll back.
We could set it to 4000 or to 1000. If you click and drag on it, you can even fine tune like this.
Okay. So if when I go in there now, let me just file save this. Go back to Unity. Let's go to my dude. I'm looking for moves. Oh yeah, I have it right there. That is really cool. It's cool as shit balls.
Did while playing. So now of course we need to change this comment here. Instead we'll change it to something like add a forward force. And it's time to have a look at doing some player input. Now the fundamental thing to understand when doing player input is the if statement. If you make some room beneath our add force method here, we can write if, open a...
Okay, if. Okay, we got that back in here so you guys can kind of see it. All right. I'm back to what I was doing. Actually, shit, I need that.
Close a parenthesis and then open and close some curly brackets.
Okay, let's try that shit. If, let's actually put another space. If some space in a curly bracket. Okay.
This is the basic structure of an if statement. If statements allow you to only execute code if a certain condition is met. This is where you put your code, and inside of these two parentheses is where you put your condition. Sometimes it's really simple, say comparing two numbers. We could write if 3 is bigger than 2. Of course, this is always going to be true, and so this will always be called. We can also say if 3 is equal to 2, and this is of course false, so this code will not be called. We can also write other stuff, say if 1 is equal to 2 minus 1, and this is of course true, or we could put not equal to, and now it's false. But this is only the stuff we can do with numbers. We can also put other stuff in here. If we want to check if the user is pressing a certain key on the keyboard, we'll go input.getKey, and here we'll also open and close a parenthesis, and in here, in quotation marks, we write the key we want. So in our case, we want D to go to the right, and now everything we put inside of these two curly brackets is only called when the user presses D. So we could of course just go ahead and add some more forces here. Let's say rb.addForce.
Okay, so this is when I input commands. Okay, if input dot get, no, I need get key down. Get key. All right, let's do. I could totally know where these keys are. Fine. Gonna come right here. Probably be RB dot. I'm calling it probably add force.
And in this case,
oh, add the force. Let's see.
To add a force on the z-axis, we want to do it on the x, meaning right and left. So we can go in here and add some numbers, say 500. We'll then do 0 on this. Hello everyone. In this video, we'll make our player move. To do that, we'll have a look at something like forward parentheses. We can also put other stuff in here. If we want to check,
I don't know how that rewound.
With forward here, and instead of the 500 here as well, you'll notice a float number. In some case here, x-axis, we hold down D, our cube code, paste it right beneath. Instead of checking for want to add a force on the z-axis, we want to do it on the x, meaning right and left. So we can go in here and add some numbers, say 500. We'll then do 0 on the y and 0 on the z. Remember to close it off with a semicolon. Of course, we want to multiply our 500 with time.delta time, just like we do up here. If we now save this, I'll just set the forward force to something pretty low,
you need. Sorry, I can't fucking type that fast. All right. Shit. And times dot time dot delta time, and boom. Undo. Weird. And save.
Up here. If we now save this, I'll just set the forward force to something pretty low, just so our cube doesn't go flying off. We can hit play, and we should see that when we hold down D, our cube will indeed move. So we can go
I'm gonna make it move. I'm gonna make it move. Where is that? I'm gonna put it 200. Oh no. Let's see that. It's too fast. Let's go back to my did. Where is the speed of this thing? Let's do 50. That is fucking fast. Okay. 20. I can't even fucking tell. It's so damn fast. Fine. 2. What a load these games now. What the shit? It just fucking fine. 0.02. Think. Oh. 0.02. I bet you don't move worse shit now, man. It just fucking Excelsior'd away. Fine. You wanna fucking play these games? Let's try that. What the? Why is it still blasting off into infinity and beyond? Let's stop that. Maybe if I just move the camera, I could try to tell for at least 2 fucking seconds. My dude, let's see. So how could you see it so damn fit? Well, first the fucking camera set behind it. I might be able to tell. I set the fucking camera behind this damn thing. Let me just fly over there. Let's just line this up with your boy. So it did do it, but it's so damn fast that it fucking blasted off into infinity.
Just like we do up here. If we now save this, I'll just set the forward force to something pretty low, just so our cube doesn't go flying off. We can hit play, and we should see that when we hold down D, our cube will indeed move. So we can go back and add this to the other.
Why is my thing going so fucking fast? Did I flip up something here? Let's check this. Go to F, wait, fix update. Where's the RB add force forward? Oh, because I didn't do this one. That's why it was so damn fast. It should be working now. No, I don't want to do that. I want to file, save. Let's go to here, and I want to go to my dude. Where's the speed? Forward force to 200. Let's try that. That's still fucking fast as shit. I mean, oh, well, it's because it's fucking didn't fucking reset. All right, let's see if that happens. Yay! That's cool. Now I just gotta Hold on. So that's that. So let's see if I could do this by myself. Next part by myself. So let's. I think.
The direction as well. To do this, we simply copy our code, paste it right beneath, instead of checking for the D key.
I thought so, yeah. So how much do I copy? Let's copy that and copy. Then paste. So it would be.
Key will check for A, and we still want to add a force on the x-axis, but we want to do so in the opposite direction, so we'll just input a minus here. Again, we can save this, play the game, and see that we can now move in both directions. In fact, why don't we go ahead and make our movement speed adjustable in the inspector the same way we did with forward force. To do that, we just add a new public float up here, and we'll call this something like sideways force. Let's just default that to 500. By the way, when we're dealing with float
Okay, so I'm just gonna do that and then public float. So sideways force. Kind of understanding this a bit. Oh, equals do 500 F semicolon. No, I mean, there we go.
variables, you will notice me writing an F at the end of the number. This just signifies that we're talking about a float number. In some cases we can leave it out, like here, but other times Unity will complain, so it's a good idea to get in the habit of just doing it every time. Again, this only applies to floats, not integers. So now we can take our sideways force and paste it instead of the 500 here, and instead of the 500 here as well. You'll notice that it's still...
Okay, so I could just take this, copy, and I change it from 500 to times, okay. Paste. Paste. File. Save. So I should. Let me just fucking stop this. Did I miss something?
Still fine putting a minus here. When we run the game, this is just going to be equal to 500, or what we said in the inspector. So let's save this, go back into Unity, and we can now see that we can...
Then I fucking...
adjust the sideways force as well. So let's try setting the forward force to something like 1000, and the sideways force to something like 600. Forward, that is still fine putting...
Let's see. RGB force. I see this thing. If get key to that. Then okay. It don't fucking work because I need to close it off and put. Then close it right there. Then I opens it back up. File, save. Now let's see. That time, this one should work. What? I'll save. What'd I do? What'd I do different? Okay, let's check it from the top. This is the forward force. So RB dot add force 0 forward force times the time delta. If input get key that RB dot add force sideways force times time delta 0 semicolon, I close it. If slash input get key a RGB force sideways times delta that should be correct, I think. Oh, wait a minute. I think I just... Now let's double check this again.
The habit of just doing it every time. Again, this only applies to floats, not integers. So now we can take our sideways force and paste it instead of the 500 here and instead of the 500 here as well. You'll notice that it's still fine putting a minus here. When we run the game, this is just going to be equal to 500, or what we said in the inspector. So let's save this, go back into Unity, and we can...
Oh, yay! So... Yay! I do this myself. Dude, that is dope as shit.
You can now see that we can adjust the sideways force as well. So let's try setting the forward force to something like 1000 and the sideways force to something like 600. And it already starts to feel like a game. If you were able to follow along with this, really good job. Programming the movement of the player is definitely not the easiest thing that you can do in Unity, and so it's always annoying that it's really the first thing that you have to do in most cases. But I hope you learned something, and remember, you don't have to understand and definitely not remember all of this the first time. I will just mention that the way that we're handling player movement here is not the most efficient way, but no one expects you to write perfect code right off the bat. I just want to let you know how this could be improved. There's two main problems here. The first one is how we're getting player input. Now, using input.getKey here is totally fine, and in our case it works perfectly, but as soon as we want to do stuff like smoothing player input, supporting alternative keys, or maybe even a controller, Unity has some much better ways to handle the player input, so you can definitely look into that if you want to improve it. Also, we are currently checking for input inside the fixed update. While it's fine in our case because what we're doing is movement, and that's usually a fairly smooth thing, it's definitely not a good idea to do for stuff like jumping or other one-off events. The reason for this is that input is updated in the update method, and if the fixed update runs slower, you might have a situation where you actually miss some player input. First, that would just mean that the input gets slightly delayed, and that's why I think it's fine here. But the recommended thing to do is check for input in the update method, then store that input in some sort of variable up here. In our case, that could just be two booleans called something like move right and move left that you'd set to true if the key is pressed and false if the keys will. If you'd like me to include in this mini-series, definitely leave a comment and I'll see what I can do. So thanks for watching, and I will see you in the next video. Thanks to all of the awesome people who donated in January, and a special thanks to Derek Heemskirk.
Dude, that was cool as shit. Like, I mean, that's crazy. I mean, sorry, I know this seems not like a big deal to some people, but I did that. I mean, granted, I looked at someone who showed me how to do that exactly, but the fact I was able to do it. Holy shit, I've been on here way longer than I anticipated. I think I'm going to cut it off right about here. And fucking just say... Fucking, what's the word? To do that. Well, thanks guys for watching. If you liked the video, go ahead and hit that like button. Hit subscribe if you want. You can see more bullshit. So my intentions, and we'll do this every day, hopefully for about an hour. That's my goal. Every Wednesday, we have, well, up until I beat the game, of course, we'll be having Game of Thrones, Ghost of Tsushima. Then I'll see you guys tomorrow. Actually, I'll see you guys tonight because today's Friday, which I will be doing a live stream of either most likely Overwatch or some other multiplayer game. So, see you guys later. Have a wonderful night.